Do you think there's a difference in the number of texts that males and females receive? It's a good question. So for their final project, a group of AP Stat students wanted to compare the texting habits of males and females. They asked a random sample of students from their school to record the number of text messages sent and received over a two-day period. Here are the data. Now notice on the top, I give you all of the data for both males and females. And on the bottom, I give you summary statistics. You could see the mean, standard deviation, min, Q1, median, quartile 3, max, and IQR. The beauty here is that when we look at this, we can see the 5-number summary, which I've circled in red. Min, Q1, median, Q3, and max. Those are the 5 numbers that help us and guide us to make box plots. So our goal is to make box plots, to figure out what an outlier is or what do we consider something unusual, and to compare distributions, in this case with box plots. With that said, I've set up a graph on the left here. I have a title on it, texting males versus females. I have gender on the left, number of texts on the bottom, and I've scaled it out counting by 20s. A little messy, but I put it in there. When I have all that in the graph, I consider that I have SLUT'd it, scale, label, units, title, and I want that on every graph. Okay, so to start with, we are going to take 5 numbers here and use those to make our box plot. But most importantly, we need to have the box part of it, and that's going to be comprised of Q1, median, and Q3. So the box is going to cut off the middle 50% of the data. So if I were to look at males, I would need to have the lower end of the box around 6, the upper end of the box at about 83, and the median is about at 28. And I'm going to call this male. Again, labels. For the females, the box starts at the lower quartile, which is now 34, and spans up to the upper quartile, which is 191. So 34 is about here. 191 is about there. So that's the lower and upper quartile, and the median is about 107. And that's going to be female. So the question in our box and whiskers is, where do the whiskers go? Now, usually I'd say the whiskers go to the highest score and the lowest score. But in stats, we've made an agreement that the whiskers going to go to the last score that is not an outlier. So let's talk about what an outlier is. Oh, go back. Well, the box is made up of the middle 50% of the data, spanning from the 25th to the 75th percentile. So we had to decide what's unusual. So the first thing that statisticians did is they took the width of the box, which is the IQR, and they said, if I take that and I move that down and I move it up, which scores beyond that upper whisker, would you think they're unusual? And they said, nah, it's not far enough away. So then someone had the bright idea, let's do the same thing with the box, but let's go out 2 IQRs. And again, they put that from the lower end of the box, which I'm having a hard time dragging that to, and then from the upper end of the box. And they said, well, gee, if I put a little fence at this upper end, would that be too far? And what the Einsteins decided, it's kind of like Goldilocks and the Three Bears, where some porridge was too hot and some was too cold. Well, they said 1 IQR distance from the lower end, upper end of the box was too close. 2 was You guessed it, too far. So where do you think they did? Yes, my friends, they split the difference and they want 1.5 IQRs. So basically, if I want to decide what's unusual, I take the width of this box, which is the IQR, and I multiply it by 1.5. And I add 1.5 of those to the upper quartile, and 1.5 of those I subtract from the lower quartile to get these fences. And these fences kind of give us a boundary of what we think is unusual. Anything outside of these fences, any scores, we consider to be unusual. So when we're doing a box and whisker plot, we will draw the tail to the last score that's not an outlier. Anything beyond that, that's beyond that upper fence or below the lower fence, we will consider unusual. So our rule is that we are going to take 1.5 IQRs and subtract it from quartile 1. That will give us the lower fence. And we're also going to take 1.5 IQRs and add it to the upper quartile. And that will give us the upper fence. And from there, we will now be able to decide what's unusual and what's not. So, I'm going to go back 1 second. Let's go over here and test this out. For the males, the IQR, which is quartile 3 minus quartile 1, is 77. We're going to multiply that by 1.5 and get 115.5. Now that's 1.5 lengths of the box. We are going to take that number and add it to the upper quartile, which was 83. And that will give us 198.5. We're going to take that number and we are going to subtract it from the lower fence, which is going to give us negative 109.5. Now note, there's no such thing as a negative number of texts. But right now we have an imaginary line for an upper fence at about 198. So right about there. Okay, I usually draw a little dotted line. And any score beyond that 198 is going to be an outlier. Now if you look at the men, they had a max of 214. So they actually have scores above that. So we can say there's one outlier at 214. Now if we go to our actual data, we can see that there's another outlier that's above that fence, which is 213. So we actually have like 2 outliers there. Well, where will the tail go? The tail will go to the next score that's not above that fence of 198.5. So if we look through the men's data, let's see, it looks like it's at 127 is the highest score that's not an outlier. Okay, so here we go. We're going to draw the tail to about 127. Now the lower tail, since there were no outliers, will go to the minimum, which is 0. Now in a perfect world, I would have written that all in green. Okay, what I'd like you to do now is to pause the video and do the outlier test for females. And then turn the video back on. Okay, let's check your work. Females. The upper quartile is 191, the lower quartile is 34, which means the IQR is 157. We're going to multiply that by 1.5, which gives us 235.5. That's 1.5 IQRs. We're going to add that to the upper quartile, which was 191, which gives us 426.5. And we're going to subtract that from the lower quartile, which gives us negative 201.5. Okay, beautiful. Now you can agree that there's no negative scores, so the minimum, which was 0, is the lowest score. And there are no scores above 426 because the maximum is 379. So the tail will go to 379. So again, the tail is drawn to the last score that is not an outlier. You must show your work for these outlier tests. You're going to subtract 1.5 IQRs from the lower quartile, add it to the upper quartile. Those will give you your dotted lines that are the fences. Anything beyond those are outliers. Now, a quick discussion of shape of box plots. There's been a lot of talk on the AP exam about the idea that it's really hard to get shape from a box plot. The first thing I want to point out is that the middle 50% can tell you kind of which direction it's skewed. If you looked at this left skewed distribution here, you could see the upper quartile here is 25% of the data in a smaller area than the lower half, which means it's going to be skewed to the left. If you look at the right skewed one, you could see again 25% of the data in a much smaller region than this upper piece, which is going to make it skewed to the right. And when the line is in the middle, it's roughly symmetric. Now, we always try to use words like roughly for symmetric because of real data will never be perfectly symmetric. Now, this can get a little bit hairy because if we just kind of look at the tails, this would look right skewed. But if I put in, what did I just do? If I put in the median there, then the middle 50% would be left skewed. So it can get really dangerous. A lot of times, like if I'm not sure, I'll describe the shape of the middle 50% and I'll say the middle 50% of the data seems to be skewed to the right or skewed to the left or roughly symmetric. The one word I never use when describing a box plot is unimodal, because if a distribution had two modes, they could easily be in the middle 50%, and you won't see that. So never say, when you're talking about its shape, that it is unimodal. That is a huge wrong. Okay, so here's kind of a final graph that's much nicer from a textbook. I don't like to write all the numbers in, but they're there. Your assignment at the end of this video now is to compare and contrast the distributions of male and females in context. So in context, I want you to compare these two distributions, meaning I want you to use comparison words in context, and you're going to use socks. And that's where we're going to start our class tomorrow. When you come in, you should be able to tell me how to make a box plot, where the fences go, and be able to have in front of you the comparison of this distribution. Good luck.